Okay, so in our second week of trigonometry, what we're going to do is go over our trigonomic ratios and use those to solve distances. So just a reminder, sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. And then I just remembered that with SO, CA, TOA. And then our new trig ratios, cosecant is hypotenuse over opposite. The secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. Or I remember that as chosh cow. And we have special triangles that we're going to look into a little bit. A 30, 60, 90 triangle, where if you look at the ratio of the short side across from the 30-degree angle, it's x. And then from the 60-degree angle, the middle leg, it's x times the square root of 3. And across the hypotenuse, it's 2x. And then looking at a 45, 45, 90 triangle, it's x, x, and x times the square root of 2 for the ratios of the two legs and the hypotenuse. Now today, in your lesson, it will be very helpful to have a calculator with trigonometry. So if you don't have, you have some options. You could have a simple scientific calculator, which will have sine, cosine, and tangent, and inverse sine, inverse cosine, inverse tangent, and then just make sure the mode is in degrees. Otherwise, on your phone, there are some free apps. If you look here, it's called TA and then Q later. So TALCULATOR. That's for an iPhone. For the Android app, it's Wabbit, WABBIT. So if you look at TA calculator, it gives you it for 14 days free and then wants you to pay $14.99 per year. But you can just X out of it and that works. So now let's look at example 1. So you have to find the indicated length. Well, if I look here, my degree is 25 degrees, and across from that is X, and then here the length of this piano is 150 centimeters. So I label what I have. This is opposite, and then over the hypotenuse. So if I had to write the equation, well, opposite over hypotenuse, that's a sine. So we're going to use the sine of 25 equals, and then we have x over 150. Well, to solve this, what we're going to have to do is multiply both sides by 150. So I'm going to multiply by 150 over here and multiply by 150 over here. Those will cancel out. And the exact answer is x is 150 times the sine of 25. So I'm going to put that in my calculator. So I do 150 times, and then the sine of 25, and hit enter. It looks like my mode is off. So if you look here, my mode is in radians and I need it to be degrees. So always check your mode first and make sure you're in the right mode. So now as I go back and get to the regular screen, I need to quit out of this. So I'm going to press shift and then exit. And then I have to retype that. So 150 times the sine of 25. And I got 63.39. So x is approximately 63.39. And then I got to make sure I have my units. The units here are centimeters, so I'm going to put centimeters. And then as we look for the second one, we are trying to find for B here. So here I have 47.2 is my theta. Across, this is the opposite side. And then this side over here is the adjacent. So opposite over adjacent is the tangent. So my equation becomes the tangent of 47.2 degrees. And then that equals 24.6 over B. So what I'm going to do is multiply both sides by B here. And then on this side, that's just going to drop out. So my next step here is B is the tangent of 47.2. And then that is equal to 24.6. Then divide both sides by the tangent of 47.2. And you would get B is equal to 24 as I get that approximation, so I'm going to go 24.6 divided by the tangent of 47.2. And I get 22.779, so that would round up to be approximately 22.78 units.